Hi, and welcome to this video on semantic ranking in Azure Database for Postgres SQL. I'm Joey D'Antoni. I'm a Microsoft Data Platform MVP, and today we're going to talk about this cool new feature. We've seen tremendous, just absolutely absurd growth in generative AI apps, and sometimes they're good, sometimes they're bad. We still deal with things like hallucination. And the success of those apps in enterprise IT workloads is frequently going to be decided now and in the future by the amount of trust their users can put in them. If those apps are spitting back crappy, bad data, then users aren't going to trust them to do important workloads. When those AI workloads generate precise, fact-based responses, users can rely on them for insight and accurate information. We're going to talk about a couple of different techniques for that, but we're largely going to focus on a technique called semantic ranking. Azure AI Search has long had semantic ranking, but now semantic ranking is available in Azure Database for Postgres. And we're going to introduce a powerful way to embed semantic ranking directly into your query results. As we mentioned, Gen AI has come a long way, but accuracy remains a challenge. During last month of the NFL season, I heard a commercial for IBM Watson where they said, our Watson AI is 90% accurate. If I told you 10% of your queries were going to be wrong, that would be a pretty bad outcome. So those aren't the kind of outcomes we're going to see. There are some ways we can improve Gen AI. One of the more common ones is what's known as Retrieval Augmented Generation, or RAG, which helps by grounding responses from the AI model in factual data. And this is typically when you add your own data sets to the AI model. As data sets grow, however, or documents become too similar to each other, even using RAG can lead vector search, which is what we call where we're searching over these vectorized values. Those things can falter, and what will happen is your users will lose trust and you lose your promises of improved productivity. Some other ways we can improve accuracy include optimizing the information retrieval pipeline, like chunking data, generating larger embeddings, and hybrid search models, to these advanced dataset specific techniques like semantic ranking. The effectiveness of these techniques is going to depend on the data set, but here we're going to focus on semantic ranking because it is one of the more universally applicable techniques. We're going to talk about how we can implement this in Azure SQL Database or Azure Database for Postgres SQL, and we're also going to talk about how Semantic Ranker works. And what it does is it compares two strings of text. We'll go into this a little more in the next slide, but it takes the search query and the text of one of the items that it's searching over. The ranker, which is going to run in this case in Azure Machine Learning on a GPU endpoint, is going to produce a relevance score to see whether these two text strings are relevant to each other, or in other words, if the text holds the answer to the question being asked. Usually this machine learning model that acts as the semantic ranker is one of the variants of the BERT language model, which are fine-tuned to perform the ranking task. And the way this works here is, consider the term capital. It has different meanings depending on whether the context is finance, law, geography, or grammar. Through language understanding, the semantic ranker can try to detect the context and promote the results that fit the query intent. This semantic ranking process is both time and resource intensive. In this case, we're using a 24 core GPU VM in order to do the ranking. So very, very, very intensive. But in order to save processing time and reduce latency, inputs to the semantic ranker are going to be consolidated and reduced so that the re-ranking step can be completed as quickly as possible. And there are three basic steps here that are going to happen. We're going to collect and summarize the inputs. We're going to score those results using the semantic ranker, and then we're going to output the results, the captions, and the answers. And in semantic ranking, the query subsystem passes search results as an input to summarization and ranking models. Because these ranking models have input size constraints and are very processing intensive, search results must be sized and structured or summarized for efficient handling. And this is going to start with a BM25, which is one of our models, ranked results from a text query, or an RRF ranked result from a hybrid or vector query. Only text fields are used in the re-ranking, and only the top 50 results progress to semantic ranking, even if the results include more than 50. Typically, the fields that we're going to use in a semantic ranking are informational and descriptive. For each document, in the search result, the summarization model accepts up to 2,000 tokens, where a token is approximately 10 characters. Inputs are assembled from the title and keyword contents in the field. Excessively long strings are trimmed in order to ensure that the overall length meets the input requirements. And the ranking is scored by over the caption or any other context from the summary that fills out the 2048 token length. Captions are evaluated for conceptual and semantic relevance to the query provided. So let's dive in and see how we're going to implement this in PostgreSQL on Azure. Okay, now let's do this demo. The first thing we're going to need to do is make sure that we have cloned the GitHub repo. You can see them on the repo. The README will tell you what to do. You'll also need to have both the AZ and AZ Developer CLI, as well as the Azure Machine Learning extension. I'm going to be doing this demo on my MacBook. So I have Bash Shell available to me, but if you're on Windows, you'll want to run this code from the Bash Shell as it is Bash specific. There are a couple of scripts here that are going to automatically deploy your Azure resources for you using the Azure CLI. And you'll see that's what I'm doing now. I'm defining AZDENV, and then I'm going to do AZD up. You should note to do this deploy, you're going to need to have an OpenAI endpoint. So eventually you're going to have to grab the API address and endpoint and the key. You're going to choose your subscription as well. Likewise, you're going to have an address of your machine learning scoring endpoint and its key. But initially, as you can see here, you only need to choose an Azure region for your demo environment. One of the challenges you may have with this demo is getting the compute capacity on GPUs for the scoring endpoint, especially in a trial or sponsored account. So before you start this, you may want to check the regional availability for GPU compute of your scoring endpoint. I've sped up the video a little bit here, but we're going to get through this, and you're going to see that this Azure deployment takes roughly about 5.5 minutes to build. Once this is complete, we're going to navigate over to the Azure portal. We'll take a look at our various resources. This builds several things. So it builds your OpenAI, it builds a key vault, a storage account, a log analytics workspace, as well as an Azure SQL database for Postgres. That's going to be the key bit of your information. So as you can see, this is building. We've also built application insights. And now we're building out our Postgres model and our machine learning endpoint. Okay, now that this is complete, we can go back over to the Azure portal. We can see all of our resources. I'm going to click through here to my Postgres database to see it. Don't worry, you're not going to need to have the name of this. We're going to have a command line command that's going to store everything for you. You will need to grab your OpenAI endpoint, but let's pop back over to VS Code and see what we do. We're going to navigate into VS Code, and all these commands are here. And the first thing we're going to run is on line 49. We're going to use that source command to get all the values so we can connect to our Postgres database. One thing to note is you'll want to ensure that pSQL, which is the Postgres command line tool, is in the system path so you can do it. When you run this setup Azure AI script, you'll be prompted for both your Azure API and Azure OpenAI API, as well as Azure Machine Learning keys. You can see that here. I've edited this so you don't see my keys, but the script is going to create the database objects, as well as copy data into our main table from a file. Let's navigate while that's going and look at the code. So here we see we have Semantic Ranker demo that we're executing, and we also have Semantic Ranker. So if we look at the Semantic Ranker code, we can see where that sent our data out to be vectorized. Here in the function that we build, we can see where we're calling Azure Machine Learning Services. Now, let's take a look at the data. I've already run the query once, but let's look at our raw data. And we can see this is just data coming from full text CNN stories. And what we did in our preparation was send this data out to be vectorized. And that's what this large array of vector numbers are at the end of this. If you've seen my earlier video on vectorizing data in semantic search, you'll know some of what this means. Here you can see me run the function. It takes a couple of seconds. We edit it to be football team wins instead of football coach fired. What this shows us is the ranking, and then we can see the scores right there at the end of the record, and you'll see that in a second. And those scores are the relevance after it's been compared to other models. So taking advantage of the Semantic Ranking Accelerator for Postgres and Azure SQL Database and Azure Database for Postgres allows a significant improvement in the accuracy of information retrieval pipelines used by generative AI applications. By taking advantage of the power of semantic ranking, businesses can get unprecedented accuracy in data retrieval and ensure the success of their generative AI investments. As this technology continues to evolve, I think it will unlock new opportunities and drive Gen AI innovations across various sectors. You can leverage this re-ranking by using Azure Machine Learning, Azure Database for PostgreSQL, along with some of the other Azure OpenAI solutions that are available to you in your Azure subscription. Thanks and have a great day.